So, name is Ibupe Success, Junior Data Scientist at Harmony. So, today I will walk you start by sharing my screen so that we can then Hello guys, I'm so sorry for that. I've been having network issues lately. So let me just share my screen so that we can start right away. Can you all hear me?
Yes, we can hear you. Proceed.
Yes. So today we'll be talking about data curation, cleaning, and visualization using Python. So, next slide. What is data curation? Data curation is a means of managing data that makes it more useful for users engaging in data discovery and analysis. Data curators collect data from different sources, Data curation is the work of organizing and managing a collection of data sets to meet the needs and interests of a specific group of people. Collecting data sets is only the beginning, exactly what we do when we store data in data warehouses or data lakes. But organizing and managing are the essence of data curation, making sense or making data set easy to find, understand, and access is the purpose of data curation, like making it accessible by your team or maybe some other persons who wants to use the data set. What is the purpose of data curation? Data curation is a key component of any data-driven company because it helps to ensure the organization can make good decisions, can make good use of its data and comply with data-related regulatory and security requirements. Data curation focuses partly on understanding and organizing data information, which is metadata, the set of details that provides information about the data itself. As such, data curation practices center on understanding where and how data is generated, as well as where it is stored. That includes creating searchable indexes on the data sets being curated. Why is data curation important? Big data systems often store a combination of structured, unstructured, and semi-structured data for analysis. More data is collected from various external sources for enterprise use. By bringing order to what could otherwise be a chaotic process of data injection and use, data curation helps keep organization from being overwhelmed by the explosion in data volumes and the proliferation of data sources. Without it, an organization could lose track of data sets and users wouldn't be able to get the information they need to do their job. Ultimately, that could result in wasted resources as users spend more time trying to search for and understand data. It could also lead to inaccurate analytics, flawed business decisions, lost opportunities, and other problems that affect business performances. What are the main steps of data curation? First of all, you have to first identify data that is required for planned analytics application. Map the data sets and catalog the metadata connected with them. After collecting the data, ingest the data into a data warehouse. Examples of data warehouse are Amazon Redshift, Snowflake, Oracle Autonomous Data Warehouse. And you can store your curated data in data lake or other systems. Conduct data cleaning to fix inconsistencies, anomalies, and errors such as invalid entries, missing values, duplicate records, and spelling variations. Transform the data into a suitable format for particular analytics use. Create searchable indexes of the data sets to make them available to users. Maintain and manage the data according to ongoing analytics needs and data privacy and security requirements. Why preservation of data set is one of the major curation's primary aim, it can also include a final step, archiving and deleting data sets when they are no longer needed or become obsolete. What is data warehouse? A data warehouse is a system that pulls together data from many different sources within an organization for reporting and analysis. From there, the reports created from complex queries within a data warehouse are used to improve business efficiency, make better decisions, and even introduce competitive advantages It is important to know that a data warehouse is definitely different from a traditional database, just like search of query language relational database. Sure, data warehouses and databases are both relational data systems, but they are definitely built to serve different purposes. A data warehouse is built to store large quantities of historical data and enable fast, complex queries across all the data. Typically, using online analytical processing, that's OLAP, a database was built to store current transactions and enable fast access to specific transactions for ongoing business processes, known as online transaction processing, OLTP. So data warehousing allows you to aggregate data from various sources. This data, typically structured, can come from online, I already mentioned it, and such as invoices and financial transactions, enterprise resource planning data, and customer relationship management data. Finally, data warehousing focuses on data relevance for business analysis, organizes and optimizes it to enable efficient analytics. A data warehouse is a system used for reporting and data analysis and is considered a core component of business intelligence. Data warehouses are centralized repositories of curated data. So the reason why I'm talking about data warehouse is that it's like a repository for curated data. So when you have curated your data, they are stored in repositories, and such repositories are data warehouses. They represent repositories, different repositories. So from one or more disparate sources, they store current and historical data in one single place that can be used to answer business questions. Data warehouses are used to support business intelligence application. Business intelligence applications are used to make decisions about the operation of the business. Again, a data warehouse is usually populated with data from an operational database, which contains transactions. The process of populating the data warehouse is called extract, transform, and load. Okay, so this process cleans, transforms, and loads the data into the data warehouse. Once the data is in the data warehouse, it can be used for reporting and analysis. So I just got the differences between data warehouse and data lake. So we have difference between data warehouse and data lake. Data warehouse is the data is processed before integration. But in data lake, data is integrated in this raw and unstructured form. So before you put your data inside a repository represented as data warehouse, you have to first of all integrate it, transform it, and put it in a structured form before you store it in a repository called data warehouse. But in data lake, anything can be taken inside data lake. You can put your own, and mostly they are all unstructured. You can put videos, you can put pictures, you can put text files. They are so unstructured. So most times they are stored in data lake. So in data lake, what you find in data lake are unstructured form of data. So data has a predetermined use case, but in data lake, data does not have a predetermined use case. So in data warehouse, most times business users make use of data warehouse because that is where they have their analysis and make decisions that will move the company forward. But most times data scientists, they use data lake. In data warehouse, data is curated and adheres to data governance practices. But in data lake, data is more agile and does not necessarily comply with any governance guidelines. So you can actually throw in anything inside data lake. Unlike a data warehouse, they actually choose what they put there and it has to be just structured. So I made available graph to further explain data curation lifecycle. The research data curation lifecycle. So this is how data curation lifecycle goes. You collect the data, you do data management plan, then you archive it, you make it public, then you can also you can make it public and other people can use the data you have stored in the repository. You have to put it available. You can also make it available for reusing and all. So this is another graph for data lifecycle. This is so this explains how data is being before you have a proposal planning writing. Like if you're given a task to work on data curation, so you first of all get your proposal planning write up, then you start the project, then you collect the data, you conduct data analysis, then you start data sharing. End of project, then you deposit the data. That is called data archive, like storage. Then you make sure that your data is discoverable for reuse and all. So the process goes over again, So this is just the cycle of life cycle of data. So we are done here. Let's move on to the coding section. So here I'm going to show you. This is to demonstrate how you're going to extract data set from a HTML10K file. So when you're giving a website to go and get a data set from that website, it means, and they will tell you exactly what you need to do. Please go to so website or that has so document. Please kindly download the financial reports data set. Then from that data set, you need to give us an analysis of financial report from so year to so year. Like we want to know how well the company has been doing from 2019 to 2020 to 2023. We want to see the financial growth of the company from so year to another year.
Hi, sorry for breaking. We can not see your screen. We can only see your presentation file, PowerPoint. We can see your Jupyter notebook.
Okay, I'm actually on my Jupyter notebook right now.
Okay, you can stop sharing and start sharing again, just Jupyter notebook.
Okay. Let me share.
Okay, we can see it now.
Okay. Sorry about that. So in this section, I'm going to show you how to extract data set from a HTML10K file. So at this point, I imported necessary libraries. So it's running. I have to wait for it to run totally before I proceed. Okay. So this is the link. This is the URL address of the company, the website address of the company. This is it here. I named it as the URL. So when I run this, then to get these data sets, okay, let me copy this. Let me take it to the company. website, the documents. Can you all see my screen?
Yes, we can.
So now this is the 10K document right now. And inside this document, there are different tables pertaining to the company. And you are allowed to scrape the tables and use it to answer business questions or maybe solve the task you're being given. This is another data set. Then you scroll down. And each of these data sets has indices. They have different various indexes you can use to identify them. You can use to pull them out from this document to your Python scripts. So this is another data set. This is another one. This is another one. Let's go down and go. So what we are looking for is tables, not the text. This is another one. So this is another one. Don't worry, sorry, it's coming up. This is another one, but that's not what we're looking for. I want to show you the exact one I'm looking for that has the financial report of this particular company. Okay, look at this data set right now. See how huge it is. So this is what we are looking for. So I'm going to check the financial report of 2021, 2020, 2019, 2018, 2017. So you can even see from here. It is called selected consolidated financial data. So this is definitely the financial report of this company. So I'm looking for a way to extract this particular data set and put it in my Jupyter notebook. So let's go back to Jupyter so you see how I did it. So I used pd.read_html to read this particular file. So when I run this, so it's coming up, but let's just fix that. Okay, can you all see my screen?
Yes, sure, we can.
So if you scroll down, you see all the tables of that particular document. See all the tables. Now, how do I now identify the particular table I'm looking for? You have to use the index of that table to pull the particular table you're looking for. So let's check the length of all the tables. You can see they're about 235. So each of these particular tables inside the document has different indexes from 0 to 235. So we have tables with index of 35, 2, 1, 3, 4, to 235. So now I want to call my financial report data set. So the index is 81. So when I run this, then I'll check what I extracted. So this is the financial report. This is it here. So we can see the way it printed it out. See, it looks very disorganized, and it brought out the columns. Each columns came out thrice. Instead of once, the way it is in the document, it came out thrice. Even 2021 came out, it was printed 3 times. 2018, same thing. 2017, same thing. Even there's even 2019, but because it's still inside, it's in between 9 and 26, you can find 2018 and 2019. So you have to be careful so that you don't just select a column that is not necessary. So at this point now, I'll be selecting relevant columns because I won't have to be using the duplicate columns. I have to select the exact columns that I need. So this particular function will help me select the columns. So if you go up here, this is column 3, has the same thing as column 4 and column 5. So what I'm going to do, I'm going to select only column 3. So inside 6 and 7 and 8, so I'll just select 7. They are the same thing, but I'll just pick 7. So I'll pick 13, 19, 25, and 31. So this is, if I run this now and I run this. Now this is the data set. This is it. So I have selected the necessary columns. So from here, you can see 2021, 2020, 2019, 2018, and 2017. Moving forward. So you identify the null values and remove them. So you use a drop now function to remove all the null values in this particular financial report. Data set. So when we run this, you can see all the null values are gone. You see all of them gone. So you have to name all the columns. So naming all the columns, what I mean naming them, you can see each of my column has integer. They have numerical numbers as the name, and it doesn't look nice. It doesn't look very nice at all. So you're supposed to, each column is supposed to have a name. They're supposed to have a name text, and so it doesn't look nice. So I have to name my columns. So this portion here is to create a name for each of my columns. So for the first column, I named it 31st December, end of the year. Then the second column, I named it 2021, third, 2020, 2019, 2018, and 2017. And when I run this, so you can see that I have named the column. So I want to remove this particular, see where my cursor is. I want to remove this particular column here, this particular row here. Like I can't be having a repetition of different rows like that. So it does not look nice. So I'll have to, and it's not just the first row I'm removing. I'm also going to remove this row here, this one here. This one that has at December 31st. I want to remove it. It does not look nice. It looks like I'm trying to repeat what is up here. Also trying to repeat it down here. It doesn't make sense. So I'm going to remove two rows. So I use this function here to remove the rows. So remember, when you're removing the rows, you have to use index. Like the first one is index 0. So the last one I'm moving, the index is 16. So when I run this, so I check. Okay, see. So you can see that those rows have been successfully removed. And I need to reset my index. Does not look nice. But instead of starting from 0, it started from 5, 6, 7, 8, 9. So it doesn't look nice. I have to further clean my data set by moving I'll use the function reset index to reset my index. So when I run this, so as you can see, it has resetted my index. It started from 0 this time around, and that, excuse me, that makes it very neat. So as it resetted my index, it also gave me another column called index. So it didn't remove the old index. So what I'm going to do, I'll just use this function to remove index column. So right now we have a data set with a very proper aligned index. Started from 0, 1, 2, 3. You know, there's no missing index value. So moving forward, you see that I defined the function that will eliminate all the brackets. When you have in a financial report, where you have a bracket like this, it means that these numbers are negative numbers. It means that, see, net income loss, brackets 103,440. So it means it's a negative number. So the company put it as a negative number. So that's how most financial reports. Yes. So I built a function to remove the negative numbers, remove the brackets I need. So what I did here is I said if this, I listed all the characters, which is open brackets and close brackets. For character in a character list, for character in this character list, if the character is equal to open brackets, and I want it to be replaced with minus. That is what it means. I use a lambda function, an anonymous function to do this. So else, if it's not so, then let it be replaced with nothing. So if you run this, so so you can see that I've been able to remove all the brackets. Then I introduce the minus sign, showing the losses and all. So moving forward, I want to check for the types. See, all the columns are, even the 2021, 2020, 2019, they're in objects. So they're objects. And I'm not supposed to visualize my data sets if it's objects. It's not right. It has to be in float or maybe in an integer. It has to be an integer for me to successfully visualize it. So what I'm going to do is so before I turn it to a float, I have to first of all remove the comma sign, the comma character, because you can't turn the comma sign into a float. It's not possible because Python sees it as a string. So what I need to do, I have to use this function here, use the same replace function to the comma signs. So you can see that they have been removed. We can no longer see the commas and everything. All of them have been removed. So I'll now go ahead and convert this to float. If you check if you check the data, you just see that the one looks. As you can see, they're no longer objects, they've been converted to float. So moving forward to visualization. If I run this, so far we've been able to extract the financial report data set from that document. So we're successful, we've cleaned the data set and it is ready for visualization. So looking at this visualization, you will see that the total assets of the company in 2021 is 32.4%. Then if you check it is about 33 million plus. So if you look at this total investments done so far by the company, you see it's about 20.4%. About the total investment is over 21 million plus. So if you look at the reserve for claims and claim expenses and all, is about 12.7%. So when you scroll down, you see all the transactions and activities the company had, even the acquisition expenses and all. So this color represents different activity on this bar graph. So on this pie chart. So we remove this one. So you see the bar chart of 2020 yearly financial report. Total assets 32.6% over 30 million plus, 20 million plus and all. Let's move forward. That's what you see. I used pie chart because pie chart best explains this stuff. Because if you best explains, so if you check 2017, you see that in 2017 the company had the highest total assets. They acquired the highest assets so far, which is about let me check. Okay, I think 2021 had the highest assets so far, which is 33 million plus. So I would say as the company moved forward, the number of assets they acquired increased. So which means that the company is doing very well. So this is something to. So this is 2017. You see that the company had an asset of close to 33.8%. So you see that the amount is about 15 million plus. So which means that at this point, the company's asset was still trying to balance and trying to increase. And as the year went by, the increase in assets and the increase in investment, and I guess as as the year increases, as the year went by, they also, their losses increased too. So they had very minimal losses too. That's what visualization helps you to do. It gives you overview of the insight or how far the company has come or how well they have come so far from the time they started and their current position. So I don't know if you have any question. Please kindly send it to the chat so that we can attend to them. Okay, someone asked, how did I know the index is 81? All right, that's a very good question. So you're going to, how you're going to know that the index is 81? You have to go to the documents. You have to start counting from here. Start from the beginning of the documents. Now, this is the first table, and I counted it as 0. The second table, this is the second table, because all these are treated as tables. Okay, so this is 1. Then the next table is counted as, this is 3. So you have to, and this is 4. So you have to, this is 5. You have to keep going down and count all the tables until you get to the one you want. Then from there, you now know, okay, this is the index. So from there, you go to Python and use that, you use that same index to call forth the data set you're interested in. I don't know if I've answered your question. Have I answered your question? Hello? I don't know if I've answered, but I believe I've been able to answer your question. So if you have another question, kindly ask me before we call it a day. So going further in answering that question, I will say, okay, when you go back to the document, you have to keep counting. You have to keep counting all the tables, and you have to make sure you are very accurate. Definitely, there's no other way to get to extract the data set you're looking for except through indexing. You have to use the index of that data set to call for what you're looking for. So when you scroll down, so you have to keep counting the tables until you get to the table you're looking for. You know, I can't start counting them because I've already done that before. So I'm just showing you, you're going to be counting all the tables until you get to the one you're looking for. And from there, you know the number of that table. So the number shows the index. In fact, the number of the table and the index are equivalent, they are the same. So it's the number that you use as index to call the data to the Python script. Or even let's say to download it. So, but you know it's not download because I didn't get it via download. I extracted the data. So that's how you get all your data from any document. Especially if it's a 10K document or maybe it's a HTML document. Whether it's 8K or 8Q or 10Q. So that's how you get them. I don't know if I've answered your question, Sha. Please, if you're still confused, kindly send me a chat. Let me know. Okay, someone is asking, why did you remove all the non-values? Won't it affect your data evaluation? You know why? If you don't remove the non-values, you can't be able to convert none to float. It will tell you can't convert string to float. So you have to remove the non-values, and it's going to affect the accuracy of the data set. If you keep the non-values, the accuracy of your data set is no longer be accurate. In fact, the data set will no longer be accurate. It will no longer be fit for analysis, and you can't derive anything from it. It still looks haphazard. It's not organized, so you can't have a data set that has no values. It has to be removed for it to look accurate, and for you to have an accurate visualization. It has to be removed. And you know, when you remove your null values, right, it reduces the number of index. That's why when you remove the null values, you have to reset your index to have a proper index in place. But I answered your question. Any other question? You guys have another question? Please kindly share. So this is the data set we're looking for. If I had continued counting from the very first table on this document and I get to this point, you will see that this data set is actually has an index of 81, or you can see that the number is 81. But I've already done that. That was my own work. So you go and count your own and figure out how you're going to get your own index. But well, I've shown you how I was able to extract this particular data set. So that is it for now. So in the absence of no question, I'm going to call it a day. Thank you so much for joining this section. I really appreciate your presence. So please don't forget to read through the instructions in your project and follow the two links. You have to choose among the two links provided for you, you have to choose one of them. It's either you choose Coca-Cola or you choose Amazon. Then you can use any of them to extract your table, conduct data curation, and build visualization. Then after that, just know you're going to store your data set in a repository so that it can be reusable. So thank you so much for this session. I'll stop sharing my screen now.